So this is grade 1 distribution math. We're going to cover some math problems that you'll find on the grade 1 exam. They won't be word for word, but they'll be similar. This is so you're familiar with it, comfortable with it when you go in to take your exam. When you go in to take your exam, you're going to have the ABC math formula conversion tables. Just to make it easy, we call it the ABC math formula sheets. The first problem, find the area of a rectangle with a length of 12 feet and a width of 8 feet. So if we look on the formula sheet, what we're looking for is, we know it's going to be a length of 12 feet and a width of 8 feet. So these formulas are listed in alphabetical order. We're looking for area of a rectangle. And when you look it up on your math formula sheet, it's area of a rectangle equals length times width. So we'll talk about units of measure, right? Units of measure, in this case, it's area. It's got length, which is in feet, and it's got width, which is in feet. So this is 2 dimensions. Length times width, that's the area. So I wrote down, and I do this the same way every time, whether I'm at my desk, I'm in the field, or I'm taking a state exam. I always do this step by step the same way, so it's consistent. I was never the best math student when I was in school. I've always struggled with algebra. This makes it very simple for me to understand because I do it the same way every time. Plus because I've been in this industry for several years, I'm very familiar with with the industry math. So I'm very comfortable with it. So first thing I do, write down the formula, and then I rewrite it with all the factors involved. So I want area, and it's going to be in square feet, equals the length, which is 12 feet. Now, the unit of measure, I write it just like this, 12 feet over 1. So when you write down feet over 1, it's the same thing as writing feet. It means the same thing. But this becomes important, especially as we progress through the different types of math problems you're going to encounter with all these different disciplines: distribution, collections, wastewater treatment, water collection, or water treatment. So length equals 12 feet over 1, and then the width is 8 feet over 1. Now this is why it's simply a simple example of why this is important. I want to know that my formula is correct before I even use my calculator to figure it out, to solve. I'm looking for square footage. When you multiply feet times feet, you get square feet. So I can say, well, the foot is over the division line, foot, division line over 1, foot, division line over 1. I can't cross cancel anything out because these are both above the division line. So here's 1, here's 2. That gives me the unit of measure I'm looking for. So now I'm confident that when I multiply 12 times 8, I'm going to get the correct answer. And the correct answer is going to be 96 feet squared. 96 square feet. You want to get in the habit of being able to verbalize the unit of measure that you're working with, especially when you're trying to solve, right? So you know it's going to be in square footage. You're going to multiply 12 feet times 8 feet. It's going to give you 96 square feet. So the second question is, calculate the area of a circle with a diameter of 12 feet. There's a couple of different ways to do this. You'll see in your math formula sheet, area of a circle. You have 2 choices, 0.785 times the diameter squared, or 3.14 times the radius squared. 3.14 is pi. The best advice I got several years ago when I first got into this industry was a friend of mine who said, pick one and use that one. Always use that one. Anytime you're doing a circle or a cylinder, any kind of circular object. And what I chose years ago was the 0.785. So what I do, 0.785 times the diameter and the way it's written is diameter squared, which is like this. Now you're going to see that when I rewrite the formula, I do it a little bit differently, but it's the same formula, works the same way. Now, just real quickly, I want to tell you that a circle, you have a circle. The outline of the circle is the circumference. When you go all the way across from one end to the other end, this is the diameter. And then when you go from the very middle to the furthest point, which is splitting the bottom part in half, you have the radius. So when we talk about a pipe that's 8 inches in diameter, it's how far apart is it? How wide is it, basically? So, keeping that in mind, I'm going to rewrite this formula with the diameter of 12 feet. So, area, and the unit of measure I want, area. Area is the same thing as square feet. So I want area square feet equals 0.785. Now, real quickly, I just want to point out, whenever I have a decimal point and there's no numerical value to the left, if it's less than 1, I always write that 0. One of the reasons I do is because my mentor in wastewater treatment, back when I first started in this industry, we would do our lab tests and record our results. It's, if you write 0.785, if somebody behind you doesn't see that dot, that decimal point, they might read it differently. So when you have a numerical value less than 1, it's a good idea, it's a good practice to just write it like this. And that's a personal choice. It's up to you. It's up to your supervisor how he wants it done when you are writing in hand. So 0.785, I'm going to multiply that by the diameter. Diameter, which is 12 feet. And again, I write it 12 feet over 1. And then I'm going to write it the diameter again. 12 feet over 1. So I'm multiplying 0.785 times the diameter of 12 feet times the diameter of 12 feet again. Before I do that, I'm just going to count it up. I'm looking for area in square feet. I have this unit of measure, foot. A second one, foot. That's 2 of them. That's the unit of measure I'm looking for. So when I multiply that out, and I've got students here with calculators, and they're going to tell me what the answer is.
113.04.
113.04, and that's
Feet squared.
feet squared, square feet. That's the square footage.